Hello, 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 hello. So I would like to touch on uh, section 5.4 and 5.5 in this video. Now in section 5.4, we are looking at the standard or vertex form of quadratic function. And we also want to look at the graphical approach. Now, we've already spent some time talking about the general functions. And we've talked about f of x equals ax squared plus bx plus c. And we did talk about why a should not equal 0. Now we want to talk about the standard form of quadratic expressions or quadratic functions, sorry. And this is the standard form. F of x equals a in parentheses x minus h, then it's closed, squared plus k. H again should not equal 0. Now, this is the standard form. And what we are saying is that with the standard form, the vertex is always going to be hk. The equation of the axis of symmetry is x equals h. The equation of axis of symmetry is always the x value of the vertex, right? We talked about that. So that is going to be x equals h. All right. Now, with the standard form of a quadratic function, what is the domain going to be? The domain, again, is going to be all real numbers, negative infinity to positive infinity. And we have an interval notation here. For an inequality notation, of course, we're going to have that. Okay, all real numbers, or you write all real numbers. Now, for the range, for the standard form or the vertex form, the range will be found on the basis of these two cases. The first one, when a is greater than 0, which means a is positive, then the range is going to be equal to, or the range will be k to positive infinity. And I'm going to explain that. And we're going to say that k has a minimum value. K has a minimum value, or k is the minimum value. Okay, the function has a minimum value k, or y equals k. That is for case 1. And what about case 2? So case 2 is when a is less than 0, which means a is negative. Then the range is going to be from negative infinity to k. Again, the function will have a maximum value k, or y equals k. So you would see that for case 1, our a is positive, which means that our k is the minimum value of y. So y equals k. K is the minimum value. And for negative, or when a is negative, k is our maximum value. Now, if you remember from what we did previously, we saw that when you have a to be greater than 0, the graph will open up, right? We said that. Now, when the graph opens up, we know that the domain is all real numbers. But what about the range? And the range is the set of y values, right? The possible y values or output values. Now, let's look at this graph and talk about the range. Let's say that I tell you that this is -3 here, which means that our point here, which is the lowest on the graph, right? And which is our vertex? Which is our vertex? And we are saying our vertex for a standard is hk. Now, k is the y value of the vertex. So this part here will be -3. This k will be -3. So we are saying that when a is greater than 0, we are going to have a minimum value of y. The minimum value of y is going to be our k, and that will be the y value of the vertex. And because the graph opens up, the y values will keep going till forever, right? Till infinity. And this is why we are saying that when that happens, when a is greater than 0, the function or the graph opens up, then our k is going to be our minimum value. We are going to have a minimum value of y. And what is that minimum value? K, or -3 for this question. Now, -3 is part of the values for y, right? It's part of the values for y. So you shouldn't do that. Because when you do that, you're saying that y is greater than -3. So -3 is not part of the values. So you have to do that. And that is why we have this, a bracket. That is why we have that for k. And then for infinity, because infinity is not a number, we do that. So this becomes our range when a is positive. And our k here is going to be a minimum value. Our graph or our function is going to have a minimum value of y equals k. Good? All right. Now, let's look at when a is less than 0. Now, when a is negative, the graph opens down. So we have something like that. Now, again, let's look at our vertex. Let's say that at this point, y is 4. So we have k is 4, right? So let's do that. The y value is 4. Now, you would see that the y is going negative, right? So it's going to negative infinity. And this is when a is less than 0, or when a is negative. So our y starts from it starts from negative infinity, and it goes to +4. So 4 becomes our minimum value, our maximum value, the maximum of y. So when the graph opens down, or when a is negative, our graph would have a maximum value. Because here it's coming down. So it's all negative. Coming down is less than 4. All the values of y are going to be less than 4. So when a is greater than 0, we have a minimum value. When a is less than 0, we have a maximum value. All right. Now, this is a worked example, and we are supposed to go to our calculator and then get a graph. And we also have to find the vertex, the equation of axis of symmetry, the horizontal intercepts, the vertical intercept, the domain and range of the function. Now, because our vertex is hk, I would first of all look at the standard form of a quadratic, and then compare it to what I have here, right? And we just looked at the standard form, a, and then in parentheses, x minus h closed squared plus k. So we are going to compare this to what we have here. Oops. To what we have here. So we have a, or f of x, equals a in parentheses x minus h squared plus k. That is what we have. Now this is the function we have. -2x minus 3 squared plus 0. You see that? Because our k is there, but it's 0. That's why it seems like we don't have a k. Now, if you look here, you know that your a is -2. So the graph is going to open down. I know that, even before drawing the graph or getting the graph on the calculator. Now, this is very important because you have to make sure that your signs here are the same. I have a minus and a minus. So my h is going to be 3. Then my k is 0. There we have it. So my vertex is 3, 0. Now, if my vertex is 3, 0, the equation of axis of symmetry is going to be my x value of the vertex, which is 3. So x equals 3. Again, make sure you do x equals 3 because it should be an equation. Don't just write 3. X equals 3. All right. Now, what about my domain? Now, for my domain, it's going to be all real numbers, -infinity to +infinity. Now, does the graph open up or down? It's going to open down. Why? Because a is negative. A is less than 0, so it's opening down. Now, will the graph have a maximum value or minimum value? Here, we know that this is going to be the maximum value because it's going down to -infinity. Maximum value. Now, what would the range be? What would the range be? Remember that our range, because we have a to be less than 0, we're going to have from -infinity to k, and k is inclusive, like that. K is inclusive. And what is k from the vertex? Is 0. So we're going to have 0 here. So it goes from -infinity to 0. And from the graph, from 0 is going down, right? And that's it. Okay. Now, what about the horizontal intercept? Now, we could use the calculator to get that. So let's go to the calculator and then use it to get what we want. So I'm going to go to the calculator, I'm going to go to y equals, erase this, and then I'm going to put in the function. And what was the function again? Let me go check. It was -2 or -2. We have -2. Oops. So we had -2, and then in parentheses, x -3 all squared. And that's it, +0, but you don't have to add +0, right? Now let me go check my window. Okay, it's a standard window. X -3. And then I'm going to have a squared. And then I'm going to do zoom 6 again. Yeah, now it's better. I don't know why. Maybe I put in something wrong. But now it tells us that yes. Now you would see that I knew it was wrong because of the vertex. So here the vertex is 3, 0, as we have. Okay, the vertex is 3, 0, as we had. All right, okay. Now, what about this? Is what I get from my graph because I have a standard window. Now, here you don't even have to, find the x-intercept because you already know it. It's the vertex, right? Because the vertex is 3, 0. So you know that. The vertex is 3, 0. Y is 0. And we know that it's only one x-intercept. So you have 3, 0, and that's it. And then you draw your graph. Okay? And then you draw your graph. All right. Now, let's try this one. So for this one, it says the first thing it's asking for is the vertex. Now, what is the vertex again? How can we find the vertex? Let's compare it to what we have here. A x minus h. plus k. Now my a is 1/2, so I know that, but the vertex is going to be hk. Now what is h? I've got a minus here. Oops. I've got a minus, and then I've got another minus here, so that works perfectly for me. So my h is 2. Now what about my k? Remember, I've got a plus here, I've got a minus here. So this means that my minus 3 or negative 3 is going to be plus negative 3, like that, right? So you have a plus and then a plus. So you have negative 3, so k is negative 3. Now what is my equation of axis of symmetry in that? What is my domain, or real numbers? What is a? 1/2. Remember, a is it's positive, so it's going to open up because a is positive. Okay, it's going to open up because a is positive. And then it says we have to find the range, and we have to find the range. So what is the range going to be? Remember, we're saying this opens, it opens up. So we're going to have that. Now, what is the vertex again? It's hk. And what was our h? Negative 2, and we had 3. So this is going to be our k, and it's going to go up. So our range is going to be k, which is 3, and it's going to positive infinity, right? It's going to positive infinity. Now, what about the horizontal intercept? We have to go back and then find that on our calculator. We have to go and then find that on our calculator. So let's do that real quick. So to do that, again, we go to y equals. We've got to erase this equation. y2, I'm just going to leave it at 0. Now we had 1/2, right? Or you could do 0.5 or 1/2, it doesn't matter. And then again, it doesn't matter, 0.5 or 1/2, it's the same thing, right? It's the same thing. So 1/2, let me go check out the equation again. I forgot what it was. But we know that the graph is going to open up. We know that. Oh, I thought I was sharing my calculator. Okay, so let me share the calculator again. So to do that, I'm going to have, let me share that. Okay, there we go. So this was what I was doing. I thought I was sharing it. So let's go back to that. So we have 1/2, and then in parentheses, x minus 2, and then squared. Okay, so let's do that. X minus 2, and then you close it, squared, and then I think there is a minus 3 here, then 0. And let's try to graph it. Let's see what we have. Oh wow, this is what we have. Now look at the vertex. That's what I'm always going to look for first. So we had, what was the vertex again? Let me go check. 2 and then negative 3, something like that. 2, negative 3, yeah. 2 and then negative 3. 2 and then negative 3. 2 and then negative 3 for the vertex. 2 and then negative 3. All right. Now here you know that the x-intercepts are going to be 2. And that's what we're trying to find. Let's go back to y equals and then see if we are all set. Window. Okay, I think we're good. Second, out, 5. Enter, enter, enter. So what do we have for the first one? 2 decimal places, that's fine. So negative 0.45. Now what about the second one? Again, make sure that y is 0 here because that's what you're looking for, the x-intercept. So second, calc, 5 again. And then I'm going to move it closer to what I need. And then I hit enter, enter, enter. Oh, and then I have 4.45 for the next one. Okay, that's it really. And then you draw your graph. You draw your graph. All right. Now, this is another one. I'm not going to go through all of it, but I want to quickly touch on some things. Now, for the vertex, remember, we always have to compare it to the general form. Ax minus h squared plus k. Now, a is negative this time. Because it says minus, you know that there is a 1 hidden here, right? So you have -1. So it's going to open down. Now when you look at h, this is the problem, and this is where students make mistakes. That here you have a minus for the standard form, and here you have a plus. That's a problem. So this tells me that if I'm going to make sure that this guy here is fixed the same way as this is, then I'm going to say that I have f of x equals minus x. It's a plus 2. But because I want to set it up as this guy, I'm going to think of it as being minus 2, like that. Squared minus 3. You see that? We know that negative times negative is positive. So this is positive though. But because we want to set it up to fit this so that we find our h. And with this, you know that h is what? -2. And what is k? This is plus. This is a minus. Again, set -3 up to be positive times negative, right? So that you have a positive. So k is -3. So my vertex is going to be -2, -3. My equation of axis of symmetry is that. My domain is that. My a is -1. And we are saying that because of that, the graph opens down. Because the graph opens down, k will be the maximum value, right? It's going to -infinity. So our range is going to be k -infinity to k, which is part of the y values. And then you find your horizontal intercept. Again, you go to the calculator and then you find that from the calculator. All right. And then you draw your graph. I mean, you know how your graph is going to look like. You know that. So that shouldn't be much of a problem because you know it's going to open down. You know that. So, all right. Now, what will the y-intercept be? What will the x-intercept be? Sorry. What will the x-intercept be? Now, let's quickly, I'm going to give that to you because I'm not going to go to the graph again. You know how to get these from the graph. So what would this be? Let me give that to you. I have it solved somewhere. It's going to be none, because it's not going to cut the x-axis. It's going to be none. Okay, none. And then for the y-intercept, so here we have none. For the y-intercept, how do we find the y-intercept? X equals 0. So put that in the function. F of 0 equals minus, what was it, x? So 0, let me write the function here. Minus x plus 2 squared minus 3. So x is going to be 0. So 0 plus 2 squared minus 3. So this gives me 2 squared and then a minus 3. So I'm going to have -4 minus 3. Remember here, the square does not affect the negative, right? It doesn't affect the negative. So you have -7. 0, -7. Okay, and then you draw your graph. All right. So when you draw your graph, you are going to have something like that. Now remember, you have to show your axis of symmetry, right? You have to show your axis of symmetry. So this is the y-intercept, and the vertex is -2 and 3. So we're going to be somewhere here. And I would label it -2, -3, 0, -7. And my graph will be something like that. And then I have this through. And what is this? X equals -2 for the axis of symmetry. All right. So you have that. So the x-intercept is none because it doesn't cut the x-axis. It doesn't cut the x-axis. All right. Now let's talk about quadratic regression. Remember, we've talked about linear regression, right? Now we want to look at quadratic regression. Same idea, only that we are not going to choose quadratic regression. We are not going to choose linear regression this time when we get on the calculator, but we're going to choose quadratic regression. So here again, we have a table. Now we are trying to get a quadratic function out of this table. So we are going to go to the calculator again, and then we're going to input our values from the table in the calculator. So let's see what happens. Let's see, I'm going to share my calculator again. Let's go to the table, stats, edit. So I input my values of the table. So T, so remember L1. So do enter. Okay, let's see. 1, enter. 2, enter. 3, enter. 4, enter. And these are from the table. And I have 95, enter. 149, enter. 163, enter. 153, enter. 108, enter. Okay. Now I have this. So I'm done with my table. Now here I'm going to erase all these because I don't need them. So I have my y equals ready. So I have my y equals ready now. Now if I go to graph from the table, I don't have anything yet. I don't have anything yet. So now I already input my values in here. So I'm going to do second calc, and then I go to, where is it? No, I go to stats, sorry, calc, 5, and then L1 is for X, L2 is for Y. So I'm going to say that store this equation in Y1. Now, storing this in Y1, I have to do this. Go to yvars, function, and then say Y1. And then I go to calculate. So I'm going to have my values in Y1. So this is my quadratic regression equation. Again, let's do it again. Stats. Now you go to calculate, and then you're going to choose quadratic regression. You don't choose linear regression, quadratic regression. Enter, enter, enter. Now, you don't have to store the regression equation if you don't want to, or if you don't need it, right? Because you could always write it down and then put it in for y. But if you want it to store up in y for you, then you have to do that. 1, and then y1. Then you go to calculate. enter, then you have this. Because I store the equation in y1, oh yeah, I have it here. You see that? And then I have my quadratic function graph now. But I have to fix this. It shouldn't be a standard window because of the values, right? Because of the window. Because my x goes from, let's do 0 to 10, because it started from 1. But y, the minimum y from the table was 95. So I could do 90 for my minimum y. Then go down to the maximum y. I'm going to do 180 for the maximum y. There you go, graph. Oh, wow. I've got it in a better way now. Got it in a better way now. Okay. All right. And then I have my regression equation. I have it here. Now, 2 decimal places is fine. Or if I say 3 decimal places, do 3 decimal places. Now, going back to the regression equation, calculate 5, or scroll down to quadratic regression, enter, enter, enter. This time I'm not going to store. Now, my A is right there, 2 decimal places. B is right there, C is right there, and then you put it in. Okay, you put it in, and you know that you have what you need at this point. Okay, so let's go back to what we are working with. So what do we have? Now, it tells you to state your window, so you state your window. That's about it, okay? Now, let's look at this problem. Use the regression. So we have the table below shows the height. This is problem 26. H in feet of a golf ball, t seconds after being hit. So we have 1, 2, 3, 4, 5 for time. And h of t is 81, 131, 148, 130, 87. Use the quadratic regression feature of your calculator to generate a mathematical model for this situation. Use function notation with appropriate variables. All right. So first of all, we have to go back to the calculator again. So start 1. Now my time is 1 to 5, so I'm going to leave it, but I'm going to erase L2. Clear, come down. The first one is 81, so I put 81, enter. 131, enter. 148, enter. 130, enter. 87, enter. Now, when I go to my window, I know my window is going to be in a mess. Here with this table, my x, I could keep the x, right? But my y, I remember x, you could always reduce it to 6 or 7 because x goes from 1 to 5. But I'm doing 0 to 10. Now my y, the minimum y is 81. So I'm going to do 80, or you could do 75. My maximum is going to be 148. So I'm going to do maybe 150 or 160. Let's do 150. Okay, 150. Yeah, this should be better. 150. Okay. Now, to find the regression equation, you go to calculate, and then you choose 5. Enter, enter. I mean, if you want to store it up, yeah, you do the same thing, vars, y vars, enter, enter. Then you go down, and then you have that. Okay, you have that. So it's saying that we should find a mathematical model. So we're going to do that. Now we have our values all set. Now we are not worried about the graph now. So I will go back to my workbook again. And then, oh, yeah, I'll go back to my workbook again. And then I'm going to, before that, I tried sharing this, but I think I didn't share it. So I'm going to share the calculator again. So I had these values. How did I get these values again? I think it didn't show up. So I'm just going to try to do it again. So let's see what we have. Yeah, forget about the graph for now. Let's go to stats, edit, and then I put the values in. And I was saying that t is 1 to 5. It was the same from the previous problem, so I kept it and then changed my y values. Okay, and then I did start again and went to calculate, and then 5, then enter, 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 enter. And then I have my values. Oh yeah. So I'm going to put these values in. So I'm going to go back, switch to the workbook. Okay. So switch to the workbook. Now I'm going to have h of t equals, so 3 decimal places is fine, 0.786 t squared plus b is 95.814 t plus c is 1.6, and then I have that. Now the next question says use your model to predict the height of the golf ball at 5 seconds. So h of 5, right? 5 seconds, so time is 5 seconds. Then you write everything again. Times 5 squared, which is 25. You might as well write 25 plus 95.814 times 5 plus 1.6. Okay? And this should give me 86.02. How does this compare to the value in the data table? How does it compare? When x is 5, you have 87. This value is very close to the actual data with a difference of about 1 foot, right? Of about 1 foot. So it's not going to be the same. Remember what we said about regression when we did linear regression. Because it's not going to be exact from the table, we are forcing a quadratic graph from this table. So it's not going to be the same. So here the value is very close to the actual with a difference of about 1 foot. Now what about C? Use your model to determine the maximum height of the golf ball. Round your answer to the nearest hundredth. Okay. So I'm going to erase everything and then go up. So the maximum height of the golf ball. What are we trying to find? The vertex. Remember, the vertex. The maximum height. We are looking at the y value of the vertex. Now, how do we find the vertex again? So for vertex, the x part is negative b over 2a. And then whatever you get for x, you put it in, right? So negative b over 2a. Remember, we are using our model. So from our model, what is a? A was negative 15.786. B was 95.814. So we're going to have negative 95.814 all over 2 times negative 15.786. And what would this give us for our x value? I think it's going to give us something like 3.03. Remember, we are dealing with 2 decimal places, so approximately it's 3.03. Now we're going to put this into the function, right? We're going to put this into the function to get our y. I don't have much space, so I'm going to do it at the bottom. So h of 3.03, what is our function? Negative 15.786 times 3.03 squared plus 95.814 times 3.03, see that, plus 1.6. And what will this give us? 146.99 feet. So the maximum height is about 146.99 feet, and that's it, okay? Now, what about D? Use your model in the calculator to determine how long it will take the golf ball to hit the ground. How long it will take the golf ball to hit the ground. How long would that be? Remember, we are looking at the x-intercept, because if you draw something like that for this golf ball, we are looking at this point when it hits the ground. So we are looking at the x-intercept, right? The x-intercept. So we have to go find that out. We're going to find that. So again, we have to go back to our calculator. So let's go to our y equals. I have my function here, so I go to graph. So this is what I'm getting for my graph, at least for now. So this is what I'm getting. Now I go to my window, and then I'm going to go check my window and then see if there is something wrong with it. So my minimum was 80. My maximum was 150 for y. And then for my y equals, this is what I have. Now I'm going to put y2 equals 0 here. And then I'm going to go to table and then check what I have. Okay. Now, because I input my table previously with stats and then edit, and then I have this, right? So 81 and then that, I have these values. And then I did stats and then did calc, calc, and then chose 5 and then did enter, and then calculate. This is what I got. Now, I'm going to erase this just because it's no problem, but I'm going to erase this and then do negative because I rounded. That's what I've been using for my model. 0.786. Oops. Negative 15.786. X squared. It's t, but we're going to use x. Plus 95 point 95.814 x plus 1.6, and then that's what we have here. So now we're trying to get our x-intercept. So let's see what we have here. Second, calc, 5, enter. So it gives us what we want, 6.09, we should say, right? 6.09. 6.09. So it means that our graph would hit the ground at 6.09. That's what this means, okay? At 6.09. Now, if I look at my graph, I'm going to, because I started from x equals 0, I'm going to go to window and then change this to start from 1. because that's where the table starts from, right? And then see what I get for my graph. Look at what I have. So you would see and appreciate it better now when you have 6.09 for the x-intercept, 6.09, because at this point here, we don't need whatever happens here at the behind, because here you're getting negative, right? So you don't need that. So all you need is your 6.09. Okay, all right. Let's go back to our workbook. So our intercept is going to be, or our x-intercept will be 6.09. It says round to the 100th, and that's what we did. So it will take about 6.09 seconds for the golf ball to hit the ground. All right. Now, the last part says find your model, use your model to determine the practical domain and the practical range. Now, we are looking at practical domain, so it's not going to be all real numbers. But we know that it goes from 0, and then when it hits the ground, it's seconds, right? Now, what about, because we had a graph or something like that, right? We had something like that. What about the practical range? Remember, it goes from here to there. Now, what is the maximum, the vertex, the maximum y? I think it was 146.99, right? 146.99. We calculated for that earlier, right? And this was 3.03. So we're going to have 0 and then h of t. We have this. And now you draw your graph and then you label the points. So I would do 0 to 150, and then I'm going to have I have 10 here, and then you label your points. Okay. This is not accurate, right? This is not accurate. Yeah, and then you put in your maximum and minimum. If you did 0 to 10 or 1 to 10, yeah, 80 to whatever, 160, yeah, put it in there. All right. So this is also on quadratic regression. I hope you enjoyed this video. Send your questions to me at the end. Thank you.